All right, I'm recording, so I'll try to watch my language. Hello, world. We are live on April 20th. What is that? Like, when did we start being isolated? In the beginning of March-ish, middle of March. So about a month of isolation. We're all relatively sane. We're going to take a look at outliers here. New page. So last week, we talked about outliers. Oops. There we go. Outliers. The first method was using the Iqr rule. And the Iqr rule says you set up these fences, and the lower fence for the Iqr is always Q1 minus 1.5 times whatever the Iqr is. And remember, Iqr is Q3 minus Q1. It's the width of the box in the box plot. The upper fence is Q3, the right side of the box plot, times 1.5, minus 1.5, plus, sorry, 1.5 times the Iqr. So you do that calculation, you get a number, that's the low end, and then you do this calculation, that's the high end. Numbers that fall between these two are what we expect to see in most data. Any number outside of this range is an outlier. Okay, so numbers in our data set outside of this range are outliers. And outliers are usually said to be unusual compared to the rest of the pack. So can I spell unusual today? Unusual. So compared to the rest of the group, any numbers outside this range are unusual. So now we get a new method based on standard deviation. So we've got the Sgd rule. And remember, standard deviation is average spread from the middle. So the lower boundary, let's call it boundary this time, for the Sgd rule is related to the picture I was drawing back here, where I said if you look at the middle by the mean and you count 2 standard deviations to the left, see what number that is, and then you count 2 standard deviations to the right and see what that number is, that is another way to talk about what the usual range of data should be for a given sample. And so if numbers are outside of that range, they're unusual. If they're within that range, then yeah, they're kind of like the rest of the crew. So back here, so the lower boundary here is X bar, the mean, minus 2 standard deviations, and a sample standard deviation is the letter S. And then the upper bound would be find that mean and look 2 standard deviations to the right. So anything within these two numbers is normal, and anything outside of those is considered to be unusual compared to the rest of the crew. And unusual is another word for outliers. So pretty similar to above. Numbers outside this range are unusual. So measurements can be unusually high, meaning they're above this upper one, or they could be unusually low, meaning they're below that lower boundary there. So we can take a look at that with another data set. So I'm pretty sure this data set that I started with from question number 8 had no outliers, which is good for concrete samples. Although too hard is not a problem, sometimes not hard enough can be a problem. Where's my spreadsheet? There. So let's sort these strengths just to double check. So data sort has a header row. All right, so this gives me a low of 3907 and a high of 4488. So based on the mean and the standard deviation, I can calculate that lower value, and I can calculate that upper value. And let's put a little space in there. So what I'm doing is I'm using the Sgd rule for outliers. And it says, take your mean and subtract 2 times the standard deviation to get the lower value of usual. And to get the upper value of usual equals the mean plus 2 times S there. So according to this, any numbers that are between 3,829.7 and 4,484.2 are normal compared to the rest of the group. Anything below or above this range is unusual. So my minimum is above, so here's my min, 3907, is above this, so that's not unusually low. And the upper is 4484. This is 4488. Oh, okay, so that one is a little high, right? 4488 is greater than 4484. How about the next one, 396? Okay, so this guy right here, I am going to color. What color should you be? Let's make you purple-ish. Okay, so this guy at the end there is unusually high compared to the other values based on the Sgd rule for outliers. And here's a question, do the Iqr rule and Sgd rule usually agree with each other? And the answer is no. If something's way out there, yeah, they'll agree. But things right on the edge, they don't necessarily agree on. So it could be there's a number that the Iqr rule says, nah, I don't think it's an outlier. But the Sgd rule says, yeah, I think it's an outlier. If they both agree, then you have clear evidence that, hey, what's up with this number? Why is it so far from the others? And then we investigate further. And sometimes outliers are normal. For example, I have some very tall friends, and when they're in a room with me and everyone else, they look way taller than everyone else, right? You look at them and you're like, man, they're unusually tall. But you know, most people are not too much taller or shorter than me. Just kind of depends. All right. Should we do another outlier problem maybe? Sure, why not? Let's look at the homework. Let's see, no other questions in chat. I think I got to everything everybody asked so far. Doing okay on time. Usually things get more exciting toward the end. Coefficient of variation. I got a video about that there. Z-scores, is this unusual or not? Okay, so I haven't talked about Z-scores yet. It is in the book, it is in the reading, it is in the other videos. So a Z-score, so we'll do problem number 12 here. Whiteboard, page. So what is a Z-score? It's actually pretty simple. A Z-score counts standard deviations. So I'll just give you an example before I do that problem there. Average body temperature, pretty relevant one right now. Hopefully no one is ill. Average body temperatures are about, what, 98.6 degrees Fahrenheit. There's plenty of evidence that it's actually lower than that these days, but that's another story. So this is what we call X bar, the average. There's also an average spread for body temperature. Average spread, wrong order, there we go. That's standard deviation, is what we're going to use for average spread. That uses the letter S usually, and it's around 0.7 of a degree Fahrenheit. Okay. So if my temperature turned out to be 97 point, let's see, can I subtract 97.9 degrees Fahrenheit. Let's say this is Gary. Right now, I'm usually a little below average. How far below average am I? Well, let's see, to count from 97.9 up to 98.6, I'm pretty sure I am 0.7 below average. So 0.7 degrees Fahrenheit below average. Now, that happens to be the standard deviation. So wouldn't you agree that I am 1 standard deviation below average? Standard deviation. All right, make believe that says average over there. So my z-score is a count of standard deviations, and I am 1 standard deviation below average, so my z-score must be -1, because I'm exactly 1 standard deviation below average. If you were, 98.6 plus 0.7, what would that be? 99.3. If that was your temperature, then you would be 1 standard deviation above average. Could you be a fraction of a standard deviation? Yeah, absolutely. So to calculate a z-score, if it's not that simple, what you do is you take your score, we call that x, and you subtract from it the mean. Now remember, I did that before on the spreadsheet. If you take a number in the data set and you subtract the mean, that's called deviation. And then if you divide by the standard deviation, that counts it. So you just take the deviation of some entry, divide by the standard deviation, and that's what we call a z-score. And if we look back at our rule over here, somebody is an outlier, unusual, if they are more than 2 standard deviations below average or more than 2 standard deviations above average. So this problem is just asking us to take a look at that for this example. So let me highlight this and calculate the z-score. New page, paste you in, blow you up. Hopefully that's readable. Okay, so on a recent quiz, the class mean was 70. So hopefully you take notes when you're doing these problems. So I would, on my piece of paper, I'd write, okay, X bar is 70. Standard deviation is 4.1. So S is standard deviation is 4.1. Calculate the z-score to at least 2 decimal places for a person who received the 97. So some number in our data set, that's just some X value. So X is equal to 79. So to find the z-score based on that, I first find the deviation, which is the X value minus the mean. So that would be the X value is 79, the mean is 70. And then we divide by the standard deviation, which is 4.1. So then I would whip this out in a calculator. Keep in mind, calculators sometimes require parentheses. The big fraction bar implies there's a parentheses around the top. This should be a positive z-score because this person is above average. So calculator, let's just use this one, parentheses 79 minus 70, close parentheses, divide by 4.1. Google wrapped up nice there, is to 2 decimal places. That 5 rounds the 19 to a 20, so 2.20 should be the answer here. So this person has a z-score of about 2.20 to 2 decimal places. Notice that that is bigger than 2 standard deviations because a z-score counts standard deviations. So this person is unusually high for their score. So unusually high, meaning this is an outlier compared to the rest of the class. Most of the class did not do nearly that well. So I should be able to come back here and say 2.2. Now there was a 0, but the computer won't notice the 0. This is unusual. All right, I think we're about out of time for today. Thank you for joining me. Do good math, read the book, watch videos, and maybe I'll see you tomorrow or the next day. Have a great day. Bye-bye.